We're add and subtract fractions today. We do need to recall first just how to add and subtract numerical fractions with integers. So let's recall some things here. If I wanted to do 3/5 plus 1/5, how would I do that?
4/5.
4/5. Very good. Remember, when you're adding fractions, you don't add the denominator. If I had 1/2 plus 1/2, what's that?
1.
1, because it'd be 2/2, which is 1. Very good. Those are the fractions we like. The fractions we don't like are as when I have something like 3/5 plus 1/4. Why don't we like those fractions? Because you need to get a common denominator. And in this case, what would be my common denominator? 20. So to get 20, I would multiply this by 4, and I would multiply this by 5. And I would get something over 20 when I add them together. What I need to remember is if I multiply the bottom times 4, you got to multiply the top times 4. Very good, and I get 12 here. If I multiply the bottom times 5, you got to multiply the top times 5, and I get 5. And then I can take the numerators, add those together, is 17/20. Okay. When you are doing rational functions, it's pretty much the same way. Only you're looking at polynomials instead of numbers. Good. So the first couple examples you should see, we have common denominators. So these ones we're going to like. If I'm taking 1/2x plus 1/2x, it's going to be something over 2x. So then you add the tops. 1 plus 1 is 2. It's going to simplify because there's a 2 on top and bottom. So it's going to be 1/x. And then, of course, x cannot be 0 because that would make the denominator 0. You still need to define what x cannot be. Let's try another one. So again, see how I already have a common denominator? 2y minus 1. So I know my answer is going to be something over 2y minus 1. So let's do the easy part. That's first. What I'm doing is now I'm subtracting. I'm taking -5y minus this whole polynomial. So what you need to remember is that this is subtracting the y and the 3. So whenever I'm subtracting, I like to put the subtraction in like this, so then I don't forget. So now when I combine like terms, these are like terms, -5y and -y. -5y minus y is -6y, and then the only constant term is that, so -3. Okay. You will want to look at your final answer and think, okay, is there anything to factor that I can simplify? And I kind of noticed, oh, I can factor out a -3, but by doing so, I don't get anything the same. Whoops, that should be a plus. These aren't the same. You can't cross off the 2 y's. If this were to be 2y minus 1, I could cross them off, but since they're not the same, I'm just done. And I would be okay if your numerator was this or this. Either one's fine. And y, of course, cannot be 1/2. So I'd set the bottom equal to 0, add 1, divide by 2. This one, again, common denominator. So I know my answer is going to have what on the bottom? 2d plus 1. So then I look at the tops and I have to combine like terms. So d's combine. What's 1d plus 1d? 2d. What's -3 minus 1? -4. You cannot cross off those 2 d's. Do not do that, because this is subtracting from and that's adding to the 2d. But I can factor out a 2 to see if there's something that maybe I can cross off, and no, nothing matches again. So I'm done. It's simplified, and d cannot be -1/2. We'd set the bottom equal to 0, subtract 1, divide by 2, -1/2. I'm sure you're asking the question, what happens if I don't have a common denominator? Okay, well, we need to make a common denominator just like we did with the fractions beginning of class. How do we get common denominators with polynomials? I have a little analogy for you. So here's me driving a car. And my two kids are in the back.
Wait.
Right? Just two of them. I don't know where the third one is. With Dad somewhere. Okay? So my two kids are in the back, right? And being the mother of the year that I am, of course I packed them a snack. Okay? So I give them each a bag and I say, surprise, here's a snack for you. So this kid got a bag of crackers and a Snicker bar. This kid got a bag of crackers and a lollipop. Okay, so anyone that has siblings or kids or have babysat, what huge mistake did I make as a mother? You did not give them the exact same thing. We all know if kids don't have the exact same thing, they cry, right? Huge mistake. Big, right? So, why are they crying? Well, this kid's crying because he got a lollipop and I didn't. This kid's crying because they got a Snickers and I didn't. So I reach into my purse and hand them what to make it fair? What do I give this kid? A lollipop, and I give this kid a Snickers. Now they both have the exact same thing and everybody's happy. Right? All right, how does this relate to math?
I think I get it.
Okay, so
Don't have children.
if I look at my denominators, this kid has an x and two y's. This kid has a 4, an x, and a y. So my kids right now are screaming it's not fair. Why?
Because they're ungrateful.
This kid has a 4 and this one doesn't. So I have to give this kid a 4. This kid's crying because he has 2 y's and I only have 1. That's not fair. So then I have to give him another y. Now they both have the same thing. They both have a 4, they both have an x, and they both have 2 y's.
So these numbers just come out of nowhere?
So if I multiply the bottom times 4, I have to multiply the top times 4. If I multiply this bottom times y, I have to multiply the top times y. Okay.
Just don't have children.
So the easy part is my denominator. The denominator is what both kids have. That's easy. A 4, an x, and 2 y's. The harder part is when you have to start combining the numerators because, yes, I need to multiply first, then add them together. So this becomes 20y plus 8. This becomes 2xy minus 4y. And I'm adding together, so do I have some like terms? The y terms are like terms. So 20 minus 4 is 16. Then I have this 2xy, there's no other xy terms. And then I have the plus 8. Okay, now I have one fraction, but I do need to make sure it's reduced all the way. Okay. Does anybody see what I can take out? A 2, very good. Okay, I can take a 2 out of all of these terms and get 2 times 8y plus xy plus 4. I can take out a 2 and get 2xy squared. Now, since I have 2 times something and 2 times something, I'm not adding or subtracting. I can cross those 2's off. And then my final answer would look like this. Of course, x cannot be 0 and y cannot be 0. Let's look at another example. The first thing you are going to be needed to do on these, of course, is factor, because you have to see what the kids have. So you need to factor, open it up. So I look here and I look at this, and can I factor something out? A 2. Does this, nothing factors on this one. So now I look at both of them and I notice, oh, they both have a y plus 2. So that's okay. What's not okay? What's not fair?
One has
This kid has a 2 and this
Yeah.
one doesn't.
You have a friend.
So I need to give this a 2, so then they match. But we know if we multiply the bottom by 2, we got to multiply the top times 2. So the easy part is, here's my denominator, 2y plus 2. And then I need to do the top. This is y minus, and then this becomes 6. Y minus 6, there are no like terms, so it just stays y minus 6.
Woo.
And then, of course, y cannot be negative 2, because that would make the denominator 0. 18 example, again, you need to factor. So what can I factor out of the bottom on this first one? A 3, very good. What can I factor out of this one? An x, yep. So I notice they both have x plus 3's, okay? It's this 3 and this x that's not fair. So I'm going to give the first kid what? An x, very good. I give the second kid a 3. Now both have a 3, an x, and x plus 3. So that's my common denominator, a 3, an x, and an x plus 3. But to do the tops, I have to multiply this by x, and this one, the 3. So this becomes x squared, this becomes 24, and I'd have x squared minus 24. There's no like terms. And this is quadratic, but it is not factorable. So I'm actually done. There's nowhere further I can go. X, of course, cannot be 0 and negative 3, because that would make the bottom 0. So we need to factor. What does x squared minus 9 factor into? It's a difference of squares. X plus 3, x minus 3, because 3 squared is 9. This one I can do what? Take out a 2. So you should know both have an x minus 3. Okay? So how am I going to make this fair? What are they missing? What's this one missing? A 2. This one's missing a
X plus 3.
very good, x plus 3. So that's my denominator, a 2, x plus 3, x minus 3. And a denominator, is there any certain order it has to be in? Not really, because multiplication is commutative. So you wouldn't have to have this exact order. But if I multiply the bottom by 2, you got to do it to the top. X plus 3, you got to do it to the top. So let's simplify the numerators. This is going to be negative 6x. This is going to be 4x plus 12. I do have some like terms. What's negative 6x plus 4x? Negative 2x. And then I just have the plus 12. Okay. The top I should notice, oh, I can take something out of there. What can I take out? A negative 2. So if I do that, I get this, and what can I cross off? I can cross off the 2's. So then my final answer would be this. And then, of course, x cannot be 3 and negative 3. All right, a couple more examples here. Of course, we need to factor first. So what do I multiply equals negative 6, but add equals negative 1? Negative 3 and a positive 2. On this one, what would I multiply equals 4, but add equals 4? 2 and 2. Okay. So now I look at both of them and I notice, oh, they both have an x plus 2 in common. Okay. But what I notice is that, oh, this one has 2 x plus 2's. This one only has 1. So I do need to give this one another x plus 2. And then this one's missing an x minus 3. Now they match. That's my common denominator. And again, it doesn't matter really what order. But the numerators now, this one I have to multiply x plus 2, x minus 3, and then multiply to find like terms. So 5x squared plus 10x. This one would be 4x minus 12. Okay, so now I'm looking at the terms. Here's an x squared term. Is there any other x squared terms? No. I look at the x term. Is there any other x term? Yes, 4. So that becomes 14. And then there's only one constant, so minus 12. Okay. So that looks like my final answer, but since this is quadratic, I need to ask myself, is that factorable? Okay. When a is not 1, you can do the AC test of factorability, where you take the a times the c term. So I'd have 5 times the negative 12, which is negative 60. And then the b term, which is 14. And the AC test of factorability says, can I multiply something equal negative 60, but add equals 14? If the answer is yes, then this is actually factorable. If the answer is no, then it's not. Right? And it is no. There is nothing that you can multiply equals negative 60 but add equals 14. It won't work. So I'm actually done here. Okay? But when you have quadratics, you do need to check and see if you can factor. So x cannot be negative 2 and 3. Okay, so last example here, we want to, of course, factor first. So what do I multiply equals negative 2, but add equals negative 1? Negative 2 and 1. What do I multiply equals 2, positive 2, but add equals negative 3? Negative 2 and negative 1, because double negative is positive when you multiply. Okay, and what I notice is both of them have x minus 2. So to make it fair, I need to give this one an x minus 1 and this one an x plus 1. Now they both have the same thing. That is my common denominator. So I can go ahead and write that down. Right? So now the work is on the tops, where if I multiply the bottom, x minus 1, x plus 1, simplify the numerators, you gotta multiply that, so 2x squared minus 2x. This one would be 4x squared plus 4x. Okay, now the thing, remember, with subtraction is I'm actually subtracting both of those terms. So what I like to do again is I like to put my negatives in already. So when I look for like terms, I know those are negatives. Right? I carry the subtraction up there so I see it. So then I look at x squared terms. I have a 2x squared and a negative 4x squared, which is just negative 2x squared. Negative 2x minus 4x is negative 6x, which I notice, oh wait a minute, I can take out a negative 2 and an x. So I need to factor one more step here. But what happens is nothing factors out. But if I were to be finding like the x-intercept, now it's factored and I can find my x-intercepts easier. Okay. So there's nothing to cross off, so I can just say x cannot be 2